Good morning, guys. Day 6 of Algebra 2 notes for Unit 13 for our trig notes. What we are learning today, something new. We are talking about reciprocal trig functions. When you think reciprocals, means you're taking a fraction, you are flipping it over. So there are 3 new trig functions that we haven't talked about yet, but you've probably heard the names, I'm thinking, for at least one of them before. The one I'm thinking that you've heard of before is secant, because in geometry we had secant lines. So secant is the full word. SEC is the little abbreviation that we use for it. Going along with secant is the cosecant function. So that's its cofunction. And so instead of COS, because that would look like cosine, it's CSC. Right? And then the last one is the cofunction to tangent, and that is cotangent. And so the abbreviation is the COT, so it looks like cot. Please don't call it cot. Even though you're at home and I can't hear you, call it cotangent. All right. So how they are reciprocal functions. Cosecant is the reciprocal of sine, so it's equivalent to 1 divided by sine of theta. Secant is the reciprocal of cosine, so it's equivalent to 1 over cosine of theta. And then cotangent and tangent are their own reciprocal functions. So it's 1 over tangent. All right, so they're co-functions and reciprocals is what I meant to say. All right, here's the other cool part. Think of SOHCAHTOA. So sine, cosine, tangent. Because cosecant is the same as 1 over sine, it would be the same as if you took the ratio that represents sine, opposite over hypotenuse, and flipped it over. So if you flip over opposite over hypotenuse, it would be hypotenuse over opposite. Play the same game with secant. This would be hypotenuse over adjacent. Same thing with cotangent. This is adjacent over opposite. And so if we think about it in like a little shortcut, what you're looking at is we've got ho, ha, ao. But it's way more fun if you say it as ho, ha, ao. So silly, yes. Do you sound like an idiot? Kind of, but it's fun. So that's the way to remember it. You have a triangle down here. What we want to do is go through and find the 6 trig ratios for it. So there's a couple of ways in which you can approach this one. But if you don't immediately know what this missing side length is, you can actually use a little Pythagorean theorem. So remind yourself that this would be A and B and C, and you can do 2 squared plus, we'll call it x squared equals 4 squared. Ooh, I'm right off the page there. Oops, and you can play the game. So this would give you x squared equals 12. And when you take the square root, we get radical 4, radical 3. This should look kind of familiar, because if I think about it, that's the ratios for a 30, 60, 90. So x radical 3, and 2x. So it actually means that that angle right there is 30. That's besides the point, but fun facts. So here's my angle. This is the opposite side. This is the adjacent side. This is the hypotenuse. That's what I want to focus in on. Opposite, adjacent, hypotenuse. So when I ask you to do the sine of theta, we know that's O over H. So that's going to be 2 over 4, which we can reduce to 1/2. If you do its reciprocal, that would be cosecant of theta. That would be H over O. It's the only time you get to say it's the ho in math. All right, keep that in mind. That would be 4 over 2. So that's actually going to come out to be 2. All right, now let's do cosine. Cosine, A over H. So 2 radical 3 over 4. In this case, you would just reduce this part of it. And so that would come out as radical 3 over 2. If we now do its reciprocal, secant, that would be the ha, so H over A. So flip this upside down. So I'd get 4 over 2 radical 3. Right? And keep in mind, you'd simplify it just like you did the last one, but then you have to rationalize it. So you would end up with this and then you have to multiply by radical 3 over radical 3. That would be the way that we would leave the answer there. Last ones, we got tangent. Tangent is opposite over adjacent. So the opposite side over the adjacent side would be 2 over 2 radical 3, which those simplify, and I get 1 over radical 3. And then, yes, you have to play the game of rationalizing it. And then last one, cotangent. Ayo, that's the one that's the most fun to say. So flip it over. You would get 2 radical 3, and then over 2. The 2's would simply simplify out, and you just get radical 3. So there's your 6 trig functions. You got your 3 basic ones, and now here's your 3 new ones. I promise that's it. There's only 6 trig functions. There aren't any more after that. So what you're going to be doing for today's practice is just being able to evaluate using any of the 6 trig functions. So just like we did on the day 4 notes and homework, what you're going to be doing here is when it says evaluate each simplest radical form if needed, check on your calculator. All right. To be able to check on the calculator, you got to be a little savvy here, but let's start. 330 degrees, you're going to draw it. So 330, so 90, 180, 270, 330 comes all the way over here, leaving a little gap of 30 degrees between the x-axis and where your angle stops. When you label 1, radical 3, 2, remember, if I go right, it's positive, but if I go down, it's negative. So get all of that set up. Then remind yourself what secant is equivalent to. Go back up to the top. This is the ha, so h over a. All right, hypotenuse, 2 over the adjacent, radical 3. It's actually just like the one we did above. So you would rationalize this because the radical's in the denominator, and I don't want it to be in the denominator. So I move it up to the numerator by multiplying by that radical 3, and this would be my final answer. Now, when it says to check on the calculator, what you'd have to remind yourself of is that the secant of 330 is the reciprocal of cosine. It's 1 over cosine of 330. On your calculator, there are no secant, cosecant, and cotangent buttons. There's only the basic 3. So to be able to do this, what you would do is on your calculator, maybe I'll move it over here, you would need to type in 1 divided by cosine of 330. Of course, make sure you're in degree mode, and I get 1.15 blah, blah, blah. All right, how does that help me? Well, I have to check and see if this, 2 radical 3, and then divide that by 3. There's that same decimal. All right. So there you go. Okay, so as a reminder, when we're looking at 4 pi over 3, you want to think about pi over 3 as your reference angle. So right off the bat, we know that that's our reference angle. So when I go to draw this, I can break up the top into 3 parts. So 1, 2, 3, and then I got to go 1 further. There's the 4th one. So my angle is going to come all the way around to here, draw my triangle. My reference angle of pi over 3 radians is the same as 60 degrees. So mark that if it helps. Right? So opposite the 60 or the pi over 3 goes the radical 3. Hypotenuse is 2. This is going to be 1 here. Remember, because you're going left, let me get that out of the way. Because you're going left, that's a negative 1. Because you're going down, that's a negative radical 3. All right. Now comes in the new stuff. Cotangent. That's the AO. So when you do adjacent over the opposite, here's the adjacent over the opposite, you are going to get negative 1 over negative radical 3, and then you'll rationalize it. So multiply by radical 3 over radical 3. The negatives are going to cancel as well, so we just get radical 3 and then over plain old 3 there. So just in case that looks like a negative, let me get rid of that. There we go. All right, that should be our answer. And again, if you're going to check on the calculator, you have to type it in as 1 divided by the tangent of 4 pi over 3. and you have to make sure that you're in radian mode. Part D asks you to do cosecant. So for cosecant, this one specifically I wanted to look at because you have 180. That's a quadrantal angle. And now because it's negative 180, it means we rotate clockwise. So here would be negative 180. So think about this on the unit circle. That is the point negative 1, 0. Okay. Now instead of thinking of this as h over o, right? When I think unit circle, I got to think about what represents sine, what represents cosine. So in this case, cosecant is the same as 1 over sine. And as a reminder from the notes from yesterday, the x-coordinate is the cosine of the angle. The y-coordinate is the sine of the angle. Because remember, alphabetical order. Cosine comes before sine in the alphabet, or C comes before S, and then X comes before Y. So that means it's 1 over the y-coordinate of 0. All right, well, 1 over 0, that's going to end up undefined. And if you do this one on the calculator, you would type it in as 1 over sine of negative 180. It should give you error. All right, so that would be your little check on the calculator. Okay, the next part of the notes is actually just talking about how to convert between degrees and radians, which you might have been starting to do, on your own already. So the idea is using 180 degrees is the same as pi radians. It says to convert an angle measured in degrees to an angle measured in radians and vice versa, you have to multiply by a ratio equal to 1. So this is like that dimensional analysis stuff. How we would do this if we are starting with degrees and trying to go to radians. So I'm going to write it as we have 0 degrees and I want to switch to radians. I have to multiply by a fraction that's equal to 1. So how I do that, I have degrees here and I want degrees to cancel. So the 180 degrees is going to go on the bottom. What's going to go on top is what it's equivalent to. That's equivalent to pi radians. Right? And because this is equivalent to 1, this thing right here, it won't change the value. It's just going to change the unit of measure. Right? The degrees will cancel. And what you'll be left with is an answer in radians. If I want to go from radians back to degrees, you're just going to do the reverse. So you would start with the angle in radians. And then when you want radians to cancel, the radians has to go on the bottom. So pi radians goes in the bottom. The 180 degrees would go up top. This way the radians would cancel, because remember, this is over 1. So if you need to see that, that's why. And then you'd be left with your angle in degrees. Right? So let's start with one that we know the answer to. We know that pi over 3 radians, that's the same as 60. Because that's one of our special angles. So how I would show this is if this is in radians, remind yourself, that means I need the radians to cancel. We're looking at the second method. So pi radians goes on the bottom. 180 degrees would go on top. And now it is not a proportion. You're not cross multiplying. You are multiplying the numerators together, the denominators together. So like we did back in our rational expressions unit, anything from top to bottom can cancel. So the radians on top and the radians on the bottom cancel. The pi on the top and the pi on the bottom cancels. So I end up with 180 up top over 3 on the bottom, and that will give you 60. Now, if the radian measure that you have has pi in it, there is a little bit of a shortcut. In that case, since pi radians is equivalent to 180, you could actually substitute in 180 here for the pi, and there you go. Problem is, you don't always have pi in a radian measure. You could just have 5 radians, and then there's nothing to sub in for. So that's why I show it the first way. So as an example, there's number 4 right there. If I said convert 3 radians to degrees. All right, 3 radians. And you can write rads, that's perfectly fine. You are going to multiply. I want radians to cancel. So pi radians goes on the bottom. 180 degrees goes on top. Rads for rads cancel, but nothing else cancels at the moment. So multiply together. Multiply your numerator together. So 3 times 180. Your denominator would just simply be pi. And note the directions. It says round to the nearest tenth for a reason, because this one's not going to come out that pretty. So if we do 3 times 180, that's going to give us 540 divided by pi. And we get about 171.9 degrees. Which hopefully makes sense, because think of the day with the wiki sticks. We had 1, 2, 3 radians cover not quite a semicircle, but about half. So it makes sense that that angle right there would be about 172-ish degrees. Right. Now let's go the opposite direction. So on the next page, you're going from degrees to radians. So if you have 180, we already know the answer to this one, but if you play the game, make sure degrees goes in the bottom. So 180 degrees, pi, rads goes up top. I don't care if you use a degree symbol or the degrees is a word, that's totally up to you. But the degrees cancels, the 180 cancels, and then all you're left with is just pi radians. Now, if you end up with one that's a little bit messier than that, so like let's say 330 degrees, same thing. I want degrees to cancel. So 180 degrees goes in the bottom. Pi radians goes in the top. All right, degrees and degrees cancel. It might not be obvious what cancels here. So what I want you to do, multiply the numerator together. So I would get 330 pi, and then the denominator over 180. This is where I want you to use your calculator. Take this piece of it and use your calculator, and we're going to do math frac to simplify that. So on your calculator, 330 divided by 180, math frac it, and we get 11/6. So we're going to write this as 11 pi over 6 radians. That's your answer.